I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see some basic introduction about neural networks and how it has been used in artificial intelligence and machine learning. First, we should know the neural networks are important in artificial intelligence and machine learning because they can automatically learn patterns and relationships from large amounts of data. Unlike traditional algorithms that required manual feature selection, neural networks adopt and improve through training, making them powerful tools for tasks like image recognition, language translation, speech processing, and decision making. Their layered structure allows them to handle complex nonlinear problems, which is why they are the foundation of modern AI systems such as self driving cars, chatbots, and recommendation engines. And before entering into this topic, we have seen and we have studied the various topics like problem solving, probabilistic reasoning, supervised and unsupervised learning, and ensemble techniques. And because these foundational concepts helps us understand the principles of AI and ML in simpler, more interpretable forms. They introduce how machines make decisions, learn from data, handle uncertainty, and combine multiple models for better results. Neural networks are more complex and involve layers of computation, nonlinear transformations, and large data sets. By learning the basics first, we build the necessary intuition to understand how neural networks work, why they are powerful, and how they solve problems that simpler models cannot. This step by step progression makes it easier to grasp the logic behind the deep learning. We'll see one by one. First, we'll move into what are neural network. That is, this neural networks are inspired by the human brain's structure. How the neural networks mimic how neurons in the brain work by processing and transmitting signals. Artificial neurons receive inputs, apply weights, and pass outputs to the next layer. This will discuss in the later lecture. And it composed of the input, hidden, and output layer. The neural networks are structured in layers. Input layer task take data, hidden layers process it through weight connections, and output layer produce the output. And here, each connection between neurons has an associated weight, and that determines its influence. During training, these weights are adjusted to minimize prediction errors. And finally, that each connection, that is unlike a traditional system that rely on predefined rules, neural networks learn patterns and relationship directly from data through training. Next, why neural networks matter in AI ML, that is artificial intelligence and machine learning. The first step is that it is capable of learning non-linear and complex patterns. How neural networks can model intricate relationship that linear models cannot, making them ideal for real-world problems like image and speech recognition. Next, neural networks works well with labeled data. Labeled data means what? Supervised learning, and can also find hidden patterns in the unlabeled data. Unlabeled data, we are calling it as the unsupervised learning. And once trained, neural network can apply learned patterns to new unseen data, which is crucial for building intelligent systems. And finally, the backbone of deep learning models. How we are calling this is the backbone of a deep learning model. Deep learning relies on deep neural networks with many hidden layers to achieve breakthroughs in tasks like translation and image generation. Next, core contributions to AI ML of the neural network. First one is neural networks learn the most relevant features from raw data automatically, reducing the need for manual features. A well trained neural network can accurately predict outcomes for new data it has not encountered during training. And the scalability means handles large scale data and tasks. How neural networks can process vast amount of data and scale across GPUs or cloud environments, making them suitable for industrial AI tasks. And end-to-end learning that eliminates the need for manual feature extraction. In end-to-end learning system, neural networks handle everything from input to output, streamlining processes and improving performance. Next, key AML areas using neural networks. Computer vision and the computer vision, how it is used. CNNs, that is convolution neural networks, power or image related tasks, detecting faces, object, and even emotions from visual input. And it is also been used in the natural language processing. The natural language processing, it is used in neural network process human language, enabling machines to understand, generate, and respond to text in applications like chatbots and translators. And a third processing is speech processing. Neural networks like RNN and transformers converts spoken language into text and interpret commands in digital assistants like Alexa or Shri. Nowadays we are using it. Next, time series forecasting. RNNs and LSTMs, a type of RNN, capture time-dependent patterns, making them effective for predicting future trends based on past data. And finally, that is anomaly detection. How it is used in the anomaly detection. Neural networks can spot unusual patterns that may indicate fraud or system failures, which is critical in banking, manufacturing, and cyber security. Next, types of neural networks in use. There are various types of neural networks are there. The feed forward neural network. The basic structure of this feed forward is this is the simplest neural network type where data flows in one direction from input to output, ideal for basic classification tasks. Convolution neural networks, the CNNs use convolution layers to extract features from images, making them highly effective for visual tasks like object detection. Next, recurrent neural networks, RNNs are designed to handle these RNNs are designed to handle sequential data by retaining memory of previous inputs, useful for language modeling and time series data. Transformers use an attention mechanism to process sequences in parallel, leading to powerful models like BERT or GPT for language tasks. Autoencoders compress input data and reconstruct it, helping in noise reduction, anomaly detection, and efficient data storage. Impact of modern AI ML of this neural network. First one is enabled deep learning revolution. Neural networks, especially deep ones, have triggered a massive leap in AI capabilities, powering advances that were previously unreachable. Outperformed traditional ML in many domains. Tasks like vision and language processing, where handcrafted features struggle and now dominated by neural models with a superior accuracy. And a powerful system like chatbot, Google Translate, Tesla Autopilot. From conversational agents, the real-time translation to autonomous driving, today's most advanced AI application rely heavily on neural networks. Coming into the conclusion, neural networks are the foundation of intelligent system. These models form the core of many AI systems that perceive, reason, and act in complex environment. And they help machines learn, adopt, and make decisions. Neural networks enable systems to continuously improve and respond to new situations, much like humans learn from experience, and it continuously evolving with the new architectures and applications. And this means research in neural network is ongoing with the new designs like GANs, transformers, and neural ODs, pushing the boundaries of what's possible. Hope everyone understood about the basic concepts of neural networks. The remaining things we'll discuss in detail in the next lecture. Thank you.